Hello everyone, welcome to the video lecture. Today we are going to simulate the PN Junction Diode VI characteristics using Multisim. So this is the circuit diagram we have here. So as per the circuit diagram, we need to place the components and we need to simulate it so that we can note down the voltmeter reading and ammeter readings and we can plot the graph. So let's place all the components required. So to place the components, right click and select place components, and we need IN4007 diode. So select diodes, type in I1N4007 and click OK. So it will be appeared here, and we also need variable DC power supply. So DC interactive voltage in Multisim, it is DC interactive voltage. You can vary the DC supply here from this, and we also need a 1 kilo ohm resistor. So for that resistor, go to basic in subgroup, select basic and select resistor. So by default you will be having 1 kilo ohm resistance, or just you can simply type 1k, it will show you. So click OK and place it here. And we need two measuring instruments, one for measuring the current and one for measuring the voltage. So for that, go to simulate and click on instruments and click on multimeter. So place it here, and we need another instrument for measuring the voltage. So just copy this and paste this. So we have every component we require now, and we also want ground source. So place component and sources, go to sources and select ground here, or you can simply type in ground, click OK. So now let's draw the circuit. So we completed the circuit here. So before going to simulate, we just need to set the voltage parameters. I'm going to take readings in steps of 0.5 volts from 0 to 5 volts. So my parameters are like this, so I'm going to keep it as this, like that, so that I can vary the voltage source in terms of 0.5 volts here, 0 0.5, 0 1, 1.5, like that up to 5 volts. So click OK and double click on this multimeter so that you can know which one is multimeter and which one is voltmeter. In by default, both meters are set to read the measure the voltage. So but we need amps current also. XMM1 is ammeter, so select A, amps, and this is B as it is. So we are giving this supply, so straight line need to be selected. For AC, this sine wave needs to be selected. So let's run the circuit. Run. So these readings are already appeared here, but these readings are for 5 volts, right? So we are going to vary this. For 0 volts, RPS is 0. The multimeter voltage readings and ammeter readings are 0 volts and 0 amperes respectively. So I'm going to tabulate all these values in an Excel sheet. So let's open Excel. So RPS value is the power it's regulator power supply, 0 volts, and voltage across the diode, see XMM2, it's 0 volts, and XMM1, it is ammeter reading, so 0 amperes at 0 volts of power supply. So just let's vary. for 0.5 volts. So these readings are for multimeter 409.264 millivolts. We cannot write millivolts, right? If we write millivolts just like small like this, we are not going to get the graph accurately. You won't get the graph. So for that, we just need to write E minus 3. E stands for 10 power. So 10 power minus 3 millivolts. 10 power minus 3 volts. Let's say like that. So and ammeter readings as 90.736 E minus 6. E minus 6, it indicates micro. E indicates 10 power. So 10 power minus 6 is nothing but micro. So for all the values up to 5 volts, I'm going to tabulate the readings. So I completed all the readings. So I noted down them up to 5 volts. So let's start plotting the graph here. So we will usually plot the graph V and I. We take V on x-axis and I on y-axis. So let's just select these two values up to 0 and click insert. Click this scatter, insert scatter, or you can just click recommended charts here, and this will show you various available charts here. So this is the best graph for plotting the VI characteristics. So select this and you'll be having the graph. This is for forward biased. So let's write here. So this is the graph for PN junction diode in forward biased. VI characteristic of PN junction diode in forward biased. So let's do the same in reverse bias. So this is the circuit diagram for reverse bias condition. We just need to change the diode terminals, interchange the diode terminal so that it will become reverse biased. And here we are going to change the voltage parameters here. The maximum voltage will be set to 1 volts and the increment will be 10%, so that while we varying the voltage will be in terms of 0.1 volts. So that increment value is 0.1 volts. Okay, so click all, set these values and click OK and just simulate this so that we will be having the values. So you can see here the voltage is changing in terms of 0.1 volts. So these are the readings you will get. So I already tabulated those readings. So these are the readings you will get. So just select this and insert and recommended charts and click OK. So you will be having a graph like this. So this is the graph for reverse biased. So this is VI characteristic of PN junction diode in both forward biased and reverse biased condition. Hope you all got this